So in the last class, we started with the discussion on the problem with the Jelinek Mercer smoothing model. Or Jelinek Mercer smoothing model is basically the language model with linear smoothing when the generation probability of the query term from the document is considered together with the generation of the same query word from the collection model. There basically we have also denoted it or named it as mixture model. This is basically Jelinek Mercer smoothed language model, or in short we'll be referring to it as LMJM. This is basically a linear combination when the linear combination parameter is lambda, where the value of lambda, as we have discussed, is basically in between from 0 to 1. Setting lambda equals to 0 means this part will be gone, so it will be only considering the generation probability of the query term from the collection. Setting it as 1 is basically will be cancelling this. So any word that is not occurring in the document will be getting a 0 score. So essentially, as we have discussed, we need to tune this parameter based on the collection. So for some collection, the optimal value of lambda might be say 0.8, and for other can be say 0.7 or something similar. Okay. Now, what is the problem with this linear smooth language model? So let's consider a collection having n documents and given a query which is a single term query. Okay. Let's say there are two documents from this collection, DI and DJ, both containing the query term Q, but in the DIth document, the query term is occurring 10 times. In the DJth document, the query term is occurring 5 times. And the length of DI is 100 and length of DJ is 10. So extremely sorry, it will be DJ. So what I am saying is for DI is basically 10 out of 100 terms is query term, right? And sorry, it's for DI, and for DJ is 5 out of 10 terms is query term. So there is a single term query. Single term query is occurring 10 times in a 100 sized document, and the query term is occurring 5 times in a 10 sized document. So we can understand that DI is much more informative overall as compared to DJ, which is relatively small in size. Right? Now, considering a single term query, there needs to be some information which has generated this query. Now, considering that, considering the size of the document, in this DJ document, the query term is occurring 5 times, but out of 10. So a query term, so maybe it is just a spam kind of a document where someone had used this search engine optimization technique to just plug in some very popular terms into the document to make it just containing half of it with basically query terms. As compared to that, DJ, there are 100 terms. So basically, the ratio of query terms in this document is 1/10. For DI, it is 1 out of 10. For DJ, it is 1 out of 2. But for DJ, it is a very small document. where other than the query terms, there is only 5 more terms, and for DI, there are many other terms. Now note that a document can be, I mean, if we think from the user's point of view who had submitted the query, we can understand that a document containing a document or in other words, an informative document or a relevant document for a query term having a single term, for a query having a single term, should contain some more terms as well. Because if it is, I mean, let's consider a query terms, a queue, and a document which is containing two terms, queue and some other term. Now again, one out of two term is relevant query term here, but still this should not be a relevant document. Let's say I'm searching for, say I don't know, say maybe cricket, and in the web, such as someone started writing a page on, say, cricket betting. Okay, so he had only written the title like cricket and betting, and he hadn't finished writing the body of the blog. For example, let's say this is a blog that the user some person started writing, but why before completing the body, the search engine had crawled this document. That is, the document was at that point containing only two terms. So it is a very small document, but given this query cricket is having a very good match. One out of two terms is basically query terms. So following this mechanism, so essentially a document's code will be mostly based on this. This is the important part, which is basically responsible for for scoring of the document. This is just the smoothing part. For all those terms which are not for all those query terms which are not present in the document, I'm just smoothing it. I'm just not considering their contribution as a straightforward zero. What I'm doing is I'm kind of using some smoothing technique using the collection language model or the background language model. So this is the major part. Now following this major part, here it will be basically 1 by 2, isn't it? Probability of Q given MD. So Q given MD is basically, as we have discussed, it is the term frequency of the query term in the document by the length of the document. So here in this case, the length of the document is 2 and TF is 1. So it is a huge probability that is being assigned. So this is actually the problem with Jelinek Mercer smoothing. So this will be providing a rank rank higher to DJ than DI. See. I had made a mistake. I think I have discussed this the same in the last class as well. What I intend to write is basically rank of DJ will be less than rank of DI. Following this, DI. Because score of DJ will be greater than score of DI, isn't it? So following this, as the score of DJ is higher, then the rank will be lower. That is, I'm starting from rank 1 is the highest or the highest score. Rank 2 is the next highest score and so on. Following this rank order, so basically rank of DJ will be lower, that is it will be in the top rank. But essentially we can understand that this is a very small document. So formally the problem or the drawback with this linear smooth language model is it kind of give unintended uh, weightage or unintended majority or importance to smaller documents like this. Now, here formally when we are computing the score of dy and dj, for both of them, this lambda parameter is set to the same value, even though it is a long document or the short document. So in other words, lambda is not actually not dependent on d, right? So the way to basically overcome this situation is make the smoothing parameter, that is lambda, dependent on the document size, is number of terms in the document. So earlier what we are doing is we are setting lambda to somewhere between 0 and 1, and we were scoring the document, score of a document for a query queue was computed based on, for all the query terms, lambda into probability of the query term in D or language model D plus 1 minus lambda into probability of the query term given the collection. So it was giving shorter documents and unaccepted priority, because so this is not dependent on the document. So what we'll be doing is we'll be introducing a variant of this parameter, the smoothing parameter, which will be considering the document length as well. Essentially, what we'll be doing is we'll be setting lambda to something like lambda by lambda plus document length. This is one way. So here we'll be calling it to something else, or what we can do is we can set to lambda to something like, so let me just not call this as lambda again. Let's call it to something, say, maybe say beta by beta plus d, or document length by document length plus beta. Either of them we will be using instead of lambda. So this kind of a retrieval model, this kind of a smoothing, we will be referring to it as a Dirichlet smoothing.